result.
Good afternoon, ma'am. Sorry.
Good afternoon, ma'am.
Good afternoon. Good afternoon.
Good afternoon, ma'am.
Ma'am, I have a problem, ma'am.
Yes, tell what problem?
मैम लास्ट टाइम जो हमारा लैब क्लास हुआ था मैम, आपने सबका अटेंडेंस ले दिया था रैंडमली आधे बच्चों का, फिर मैम आपने नहीं लिया था मैम। देन सेकंड जो मैम थी हमारे, मैम जो पढ़ा रही थी मैम, उन्होंने लास्ट में बोला था कि आप लोग हैंड रेज कर लो, मैं स्क्रीनशॉट ले लूंगा वो अटेंडेंस के लिए जिन लोगों का नहीं हुआ है मैम। सो मैम मेरे कंप्यूटर में शायद गूगल मीट में कुछ ग्लिच हो गया था, मैं जब भी हैंड रेज कर रहा तो ऑटोमेटिक डाउन हो जा रहा था, तो तभी
टेंशन
तो
don't take टेंशन।
यस मैम।
कुछ
तो
टेंशन
पता नहीं है कि मेरा अटेंडेंस हुआ है कि नहीं।
हाँ, उस टेंशन मत लो।
ओके
तो क्लास में थे तो
यस मैम, स्टार्टिंग से एंड तक पूरा था मैम।
मैम मेरा भी सेम प्रॉब्लम दे रहा
कुछ
था,
टेंशन मत लो, नो टेंशन रिगार्डिंग अटेंडेंस।
ओके मैम।
Good afternoon.
गुड आफ्टरनून।
गुड आफ्टरनून मैम।
गुड आफ्टरनून।
Hello.
Okay, my voice is clearly audible to all of you.
यस मैम।
Yes, ma'am. Yes, ma'am. Ma'am, you are muted.
Oh, last class what we have completed, tell me.
Ma'am, you taught us about that underground and overhead cables.
Yes, ma'am.
Ma'am, that AC voltage, current, direction, magnitude, polarity, all those.
Just wait.
We ended at
Your
staircase
voice is
lighting.
not audible. Let me see. Have I started battery? Last class?
Yes, ma'am. You have started battery. Like nickel cadmium battery, you have told.
Okay, my screen is visible.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So last class we have discussed about components of LT switchgear, general rules of wiring I have completed. Next I was discussing about the battery. Okay, battery I think I have not yet started, right? I was not audible from all of you.
Yes, ma'am. We can start from here.
Yes. So coming to the battery, you are having two types of batteries. One is primary batteries, another one is secondary batteries. Primary batteries are those batteries which cannot be recharged. Once you have used, you have to throw it. Okay. Yeah, it's because the electrochemical reactions cannot be reversed in case of the primary batteries. Okay, so the examples of these primary batteries we are using it's having a wide applications because the cost is very less. Okay, they are used in remote control, then toys, then wristwatches. Okay, so coming to the secondary batteries can be recharged. So they are costlier than that of primary batteries. So there are basically four types of rechargeable batteries. One is lithium ion, nickel cadmium, nickel metal hydride, and lead acid battery. Okay. I have already discussed. This is a lithium ion. This where you are using in smart devices, we are using this type of lithium ion batteries. These batteries, this is nickel cadmium. Where you are using nickel cadmium? Nickel cadmium also we use in many cases, but the difference between this nickel cadmium and nickel metal hydride batteries is that nickel, they looks, the size is same, but these batteries are having very high capacity and high density. Okay, and they are not susceptible to the dreaded memory effect, which the nickel cadmium battery experience. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
Ma'am.
Okay, so now these are the lead acid batteries. This is very heavy. Okay, so this is not portable, so that you can move here and there. So usually these are used in these types of batteries are in inverters, in vehicles. Okay, so these are the different four types of secondary batteries. Now next coming to the so here basically what you remember in the battery is you will remember the different types. Okay, working operation it's not required for you, and application. Okay, suppose nickel cadmium, where you are applying, where you are using. So these applications, one or two you will remember. Then next coming to the necessity of earthing and fuse.
Excuse me, ma'am.
Yes, tell. Yes,
Can you tell what are the rechargeable batteries ones?
just wait 1 second. Yes, what you are telling?
Ma'am, rechargeable batteries example.
Rechargeable batteries. Rechargeable, now, everywhere you are using, if a cost is not a factor, then most of the cases we are using these rechargeable batteries. For example, you tell me where you are using rechargeable batteries. In mobiles, you are using rechargeable batteries. In your laptops,
What are the
Ma'am,
types?
camera phones we are also using rechargeable batteries.
I am not able to get it. Again, tell me.
Ma'am, means what are the types? Means like lithium ion, nickel cadmium, and what other types?
You are telling the different types.
Yes,
Which
ma'am.
types?
Yes.
Yes,
Yes.
ma'am. But it means which type of batteries can be reused by, yes, ma'am, reused.
These four types can be reused: lithium ion, nickel cadmium, nickel metal hydride, and lead acid battery. All these four types of batteries can be reused.
Okay. Ma'am.
Okay. This you are asking, or any other question you are
Yes,
asking?
ma'am. Yes, ma'am. This the types.
Okay,
Yes.
okay, very good. I will be sending you the slides today because I will be completing today the first module. I will be sending you the slides, don't worry. So now coming to the necessity of earthing and fuse. What is the necessity of earthing? Now all of you have heard a term earthing. What is the What do you mean by this earthing? Tell me. What do you mean by earthing? Yes, tell me. Whatever idea you are having, you tell me. Yes.
Ma'am, basically earthing is to save our electricity for short circuit or overload anything.
मैम एक्स्ट्रा करंट को
मैम
Madam,
पास कर
last
देते हैं,
question.
free करते हैं।
Last for a call. हाँ, क्या बोल रहे हो? Yes, tell me.
मैम एक्स्ट्रा करंट को हटा देने के लिए लाइक
रिलीज कर देता है मैम, जो एक्सेस करंट होता है, जो ओवरलोड होता है।
Excess current कहाँ आ रहा है?
मैम
excess current-
बेसिकली शॉर्ट सर्किट एंड ऑल
Yes, tell me. One of you tell me where you are.
मैम थंडरस्टॉर्म वगैरह से जो एक्सेस करंट आता है मैम, अनवांटेड, जो हमें चाहिए नहीं होता।
Okay.
Due to lightning.
You forget about thunderstorm, natural calamity. You now simply tell me, you have pressed your iron. Have you pressed ever your shirt with
Yes,
your
yes,
steam
yes,
iron?
ma'am.
Yes.
No.
Okay, you cannot tell that yes, everything is done by your mother or father. You have done. In some cases, have you got a shock, electric shock, any time?
Yes, ma'am.
Yes.
Through the
Why?
switchboard.
Why is it? Forget about thunderstorm. You take a practical example. Why you have got a shock?
Ma'am,
Ma'am,
due to
there is
electricity,
the
body to the
electricity.
part.
Unwanted electricity flowing on our circuits.
Why there is an
Ma'am,
unwanted
because
electricity?
live wire comes in
Wire
contact
is
with
over.
the new.
Yes, that's what I was telling you. In our house, in our home, see, we are having a 3-pin plug. Yes or no? We are having a 3-pin plug like this. This one is. All of you, it's visible my board? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Visual, ma'am.
So here, this upper one you have seen, this circle is of a large diameter compared to these two. Yes or no?
Yes,
Why
please.
is it?
Yes, ma'am.
Because this carries the earthing conductor. Okay, this is your earthing conductor. What is the function of this earthing conductor? This earthing conductor is having very large area of cross section. Why is it? Because you know that this relation you have already read in your 12th standard, that when this conductor is having a large area of cross section, what happens to my resistance?
It decreases.
It decreases.
It is very, very low. Usually the earthing conductor is having 0 to 3 ohm resistance. Okay, 0 to 3 ohm resistance. Usually we are having, we cannot get a conductor of 0 ohm resistance. If you can get it, it is good. But ideally, this is what we are speaking about. Ideally, practically you will not get. So earthing conductor resistance is 0 to 3 ohm. Okay. So what happens? So suppose I am, suppose this is your steam iron. Okay. This is your steam iron. You are working with the iron. This is your body of the iron. Now what you have done? You have connected the iron to this 3-pin plug. 1, 2, another one is your 3. Yes or no? Tell me. This is your completely a plug is there. You have put it on. Got it or not? Clear
Yes,
to all
ma'am.
of you?
Yes, ma'am. Yes, ma'am.
So now this conductor has entered the body of the iron. So this conductor, because this is carrying a single phase supply, you will see one conductor is your phase, current is going and current is coming on. One is your phase, this one is your phase, this one is your neutral. Yes or no? Phase, this is your neutral. You know this or not? Yes, you must be knowing.
Yes, ma'am.
This one is your earthing. All of you got it or not?
Yes, ma'am.
Okay.
Yes,
so
ma'am.
now here, this is the phase where has come into this body of the appliance. Now, suppose there is any insulation failure. Yes. So suppose there is any insulation failure and there is a connection between a phase and the neutral. Okay. Suppose there is an insulation failure and the live wire has touched the body of the iron, because here the phase neutral conductor is going. Suppose there is an insulation failure in the phase wire and that phase wire has touched the body of the iron directly due to the insulation failure. Am I clear? When you are taking a conductor, you are insulating that conductor, right? You are not taking a naked conductor or a bare conductor. Okay. Suppose there is an insulation failure and it has touched the body of the iron. Then when you will touch, when you are working with the body of the iron, when you are pressing it, that means what you are doing? You are directly in contact with the phase of the wire. Am I clear to all of you? Am I clear to all of you?
Yes, ma'am.
Am I clear?
Yes, ma'am.
Yes, ma'am.
All of you understood or not? So quickly you are responding
Yes,
yes, madam, or to tell yes or no. Okay. So when you will touch the body of the iron, then what happens? You are directly in contact with the phase wire. So you get an electric shock. Right? Now, so to prevent this shock, what we are doing? We are grounding the appliance. Okay, that means here, suppose there is an insulation failure, then what will happen? All the current, this is connected to the grounding wire, so that will extra current will go to the earthing. Earth is at zero potential. This is at zero potential. So all this is having very less resistance. So current will flow, maximum current will flow to the which one? To the earthing conductor, and you will be safe. You are getting a shock, but that is not dangerous because due to the presence of the earthing. Am I clear to all of you?
Yes,
Am I clear to
Yes,
all of
ma'am.
you?
Yes, ma'am.
Yes, ma'am.
Okay. Earthing protects the device as well as earthing protects the human body also. Okay. So what is the necessity of earthing? So when you are using it, there is a 2-pin plug. Have you seen a 2-pin plug where you are having only 2 pins? Okay, phase, another one is neutral.
Yes,
all of you have seen. Another one is
Yes,
a
ma'am.
3-pin plug.
Yes, ma'am.
Okay, so while working in a 2-pin plug, is not, it's not, we are not suggesting to use a 2-pin plug. Okay, rather go for 3-pin plug. When you are using a 2-pin plug, then a fault will occur, then nobody can help you. Okay, a fault may occur, nobody can help you. Your system may get damaged, or your appliance may get damaged, or you may get certain accident. You may fail under certain accident. Okay, so 3-pin plugs are always recommendable than a 2-pin plug. Clear to all of you? So now coming to that. Earthing, necessity of earthing, it's because for the safety of the human life, building, our houses are, yes or no? Our houses are, then equipments are also earth. Then over voltage protection. Suppose there is any over voltage, then what will happen? The current will be high, then that extra current will flow to the ground. Then earthing is also done for voltage stabilization. That means if there is any extra current flowing or extra voltage, that will be, everything will be managed by the earthing conductor. Extra thing will flow to the ground. Okay. So now coming to the next point, the earth path should be capable of handling magnitude and duration of current as per the overcurrent protection of the system without any fire. So what will happen? What will happen if you have done the earthing properly? There will be no overcurrent. There will be no fire due to overcurrent. Okay, you must have heard some buildings there due to short circuit. This building has burnt. Yes or no? You have heard it or not? So that is due to the overcurrent, or any short circuit current has happened. Okay, so this earthing should be earthing is very important. Earthing is very important. Okay, persons in the vicinity of earth structures and installations shall not be exposed to the dangers of electrical shocks. Okay, so if there is earthing is proper, then the persons will not be exposed to the dangers of electrical shock. It is essential that earth resistance should be as low as possible. It is specified that for protective purpose, the same should not exceed 0.2 ohms. Okay. So if it is less, if it is this ohm, it should not exceed this ohm. Okay. So it usually varies. You will see that in some buildings you are getting a you will get a maximum times you will get a shock. That means in those types of buildings, the earthing is not done in proper way. Okay. So this is how earthing is done. You will find out last class I have given you a question why underground cables are not operated above 66 kV. Okay, that I have given you one question. I will ask at any time to any one of you. Okay. Second question I am asking you, you ask your father or your mother or whatever idea you are having, how the earthing of your house has been done. Okay, that you will tell me. So this is how your earthing is done. We have to dig it and you will tell me. That is question left for you. Clear to all of you? These two questions, you will find out the answer and you will tell me how the earthing is done how the earthing is being done in your house. Okay. Now coming to this fuse, have you seen this type of fuse?
Yes, ma'am.
Okay. So this is your inside, it is a fuse wire. This fuse wire will melt if there is any fault in the circuit. So this will break the circuit and everything will be in the safe side. Okay. Next, this is the last slide. So what are the different electrical safety rules? First rule is that when you are plugging any of the appliances, whether you are using your laptop or your mobile phone or any iron, whatever may be, so you should see that the power equipment should be in the off position. First you will keep it off, then you put the plug in that. You will put the cord in that receptor. Okay. Second is the electrical equipment which you are unplugging it. You should first grasp the plug and then you pull it. Never pull or jerk the cord to unplug the equipment. This is the second rule. Okay. Third one is if you are seeing that this conductor is cracked. Many times you will see that your cracked conductor you are using and you make a black tape or you use a red tape, your cellar tape to close it. Yes or no? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. Don't use those types of cracked or exposed wiring on equipment cords. If it is there, then you correct it. Okay. Also check for defective cord clamps at locations where the power cord enters the equipment or the attachment block. Okay. Next point is cheater plugs and extension cords should not be used. Cheater plugs is what you have seen in most of the cases. You will see, not in Bhubaneswar, you will see small street areas. There, the small hawkers, they will be using these types of cheater plugs. What is cheater plug? They will be having a plug. They will just take the supply from the lines. Okay, they will be having that plug, so that they will not be giving the electricity bill. That is called as cheater plugs. Got it or not? Extension cords. Clear or not? Have you seen it or not? Cheater plugs, have you seen it or not?
Yes, ma'am.
So those plugs are not advisable at all. Okay, there may be a possibility of fault. Next is temporary or permanent storage of materials must not be allowed within 3 feet of an electrical panel. Where there is an electrical panel, whether you are working in an industry or in your home, you will see that where the main electrical panel is there, Nothing, no storage material or nothing is there in between 3 feet, within the vicinity of 3 feet. Okay, otherwise something will happen inside the home or inside the building or inside the industry. Somebody will rush immediately. What is the first step? You will rush to the electrical panel and you will switch off the main switch. So it is not advisable. It is advisable that you should not keep anything in the vicinity of the electrical panel. Okay. Next point is any electrical equipment which is causing shock. If you know that yes, this is causing an electric shock, then what you have to do? You have to put a tag there. Danger, do not use. If you know that yes, there is you are getting a shock or this thing is a damage, that this is having a faulty system. Here a faulty system is there. Somebody will go and touch it and he or she will get a shock. Then always tag with a danger, do not use label. Am I clear to all of you, all the rules?
Yes, ma'am.
Okay. Clear to all of you? Is there any doubt?
No, ma'am.
No doubt. All of you understood everything? Abhijit, you understood?
Yes, ma'am.
Abhijit, Ananya, Sayan,
Yes, ma'am.
Yes, ma'am.
Divas,
Yes,
Divas, Priyam, Satyam, Priyam Ghoshal, Satyam,
Yes, ma'am.
Ranajay,
Yes, ma'am.
Siddhant,
Yes, ma'am.
Shubhra, Dash,
Yes, ma'am.
understood? Susri,
Yes, ma'am.
Shuyash Datta.
Present, ma'am. Present, ma'am.
Okay, you understood or not? Tell me. I am not calling your attendance.
Yes, ma'am. Yes, ma'am.
Okay, chalo. Next we will start module 2, which will be definitely interesting for you because that was the theory part. Second module is your DC circuit. Today I will upload the first module, okay? Now before going to the DC circuit, where we will be solving the different types of DC circuit by using different theorems, different analysis we will be using. Okay, so before going to the DC circuit, we will discuss whatever you have read it in your 12th standard. Okay, like first thing I will tell you, I will ask you, not tell you, what is an electric current? What is an electric current? Yes, tell me, quick. Tell so
Flow
many
of
students.
electrons.
Flow of electrons in a closed circuit.
बोल दिया मैंने, वही बोला.
Flow of what?
Electrons.
Never tell flow of electrons. Always tell flow of free electrons. Understood? Always the free electrons flow is responsible for the production of the current. Am I clear to all of you?
Yes, ma'am.
Your answer should be very clear. Okay, you are telling flow of electrons, just add another word, flow of free electrons. Okay, so now a question will come. Suppose I will ask you one question. Now this, understand, DC circuit is very important because you will be getting only problems from here. Okay, so your concept should be very clear from the beginning. It's not theory for like your first module. You will just remember by heart and you will write. No. So now this is suppose this is a conductor. Okay, I will give a battery source here. This is the symbol for the battery, you already know. So I will give a battery source Now what happens if I'm taking a conductor like copper strip I'm taking, okay, I'm giving a potential difference here or a battery here. This is a positive, this is negative. Then what happens, tell me? What will happen here? What will happen? Yes,
Electricity will start flowing.
and Amish,
Electric current will start flowing.
Amish,
Yes, ma'am.
tell, what will happen?
Electrons will start flowing.
Electrons will start flowing. Where electrons will start flowing? Electrons are the negatively charged. Yes or no?
Yes,
These are
ma'am.
the negatively charged. So what will happen? They will attract towards the positively
Positive
charged. Okay. So now a question will come to your mind. But current flows where? Current, you
In the
know that
opposite
current
direction.
flows from higher potential to lower potential. Yes or no?
Yes, ma'am.
Yes. So now you are telling that the flow of free electrons is your current. But electrons flows in this direction, but your current flows in this direction. Why is it?
Ma'am, actually the current is flow of positive ions, but positive ions cannot move. And
Flow of positive ions. Okay, some
by definition, it is like that.
okay. You are by definition you are telling the flow of free electrons. The free electrons are flowing in this direction, but
Yes, ma'am.
current
So
is
the
flowing in
opposite
this
direction
direction.
will be considered as electric
Why?
current.
Why is it? Why?
Ma'am,
Anybody answer me? Why? Let it be wrong. You are not getting any marks.
Empty space.
Yes, tell me. Who is answering? Suprasad, tell me.
Ma'am, what was the question? Can you repeat?
Why you are not listening or what?
No, ma'am. I got disconnected, ma'am. Some network issue.
Siddhant, you tell me, Suprasad, why the current is flowing in the opposite direction to the flow of free electrons?
Ma'am, is it due to electric field? Is that?
It is, there is nothing technical here. It was just a convention. See, these electrons are moving. This was found, or this was experienced when the electron theory was developed. Prior to that, it was taken, or it was assumed that the current is flowing from higher potential to lower potential. So that convention is there. Okay, that was the convention. So that convention, we are still now, we are firmly believing that the current is flowing from higher potential to lower potential. But from the electron theory, we found that the electrons are moving towards the higher potential. The electrons are moving towards the higher potential or towards the positive. Okay, and current is flowing from higher potential to lower potential. This was the convention only, nothing else. Anybody will ask you, you will just tell that before electron theory, it was assumed that, and because you were previously it was assumed, so we are taking that as convention. Clear to all of you? Now, coming to yes. So this is your conventional current direction. So now tell me how you define current. How you define the current. What is the unit of current? Not define. What is the unit of current? Tell me.
Ampere.
Unit is ampere, and it is denoted as capital A. All of you write here. This one I will not be sharing. All of you write with me. All of you. Say it in front of the laptop and write with me. Because while doing the problems, I will immediately tell you to show the copy or take the screenshot and send me. Okay. Or upload it in Google Classroom. So all of you write with me, because you will be working problems related to this. So now, electrons is defined as the rate of flow of, another definition of current is rate of flow of electrons. Okay, or rate of flow of charge. Okay, charge is nothing but your electrons. So current is equal to current which is denoted as capital I, current which is denoted as capital I is equal to Q divided by T according to this definition. Am I clear to all of you?
It's a balance for unit time.
So the unit of charge is your coulomb and this is your time. So this is nothing but your ampere. Okay, so how will you define 1 ampere? Define 1 ampere. Define 1 ampere.
Ma'am, flow of 1 coulomb of charge in the conductor in 1 second.
Flow of 1 coulomb of charge in 1 second. Okay, where the 1 coulomb of charge will flow? At any in a conductor, current flows in a conductor. So at any cross section, you take at any cross section of a conductor, if 1 coulomb of charge is flowing in 1 second, then you will tell that if 1 coulomb is flowing in 1 second, then you will tell that 1 ampere of current is flowing at any cross section. Am I clear to all of you? So here 1 ampere of current is said to flow in a conductor or wire. 1 ampere of current is said to flow in a wire or conductor if tell me, if at any cross section, or at any section 1 coulomb of charge flows in 1 second. Charge flows in 1 second. Am I clear to all of you?
Yes, ma'am.
Okay. So this is about the current and ampere. Now come to the potential. Electric potential. What do you mean by electric potential? Tell me. Yes, these terms, whatever I am teaching you today, it's already known to you in your 12th standard.
It is the amount of work needed to move a unit charge from a reference point to a specific.
Tell.
Ma'am, amount of work done to bring a charge from any infinity to a point.
To a specific point, ma'am. Against an electric
field. Yes. Any other definition? Any other?
Ma'am, the amount of work to move a unit charge from a point, from a reference point.
Ma'am, the amount of work done to bring unit charge from infinity to that point.
Why so difficult sentences you are telling? I do not know. Why so difficult? Why so difficult sentence you will tell? It is the electric potential means what? When you are talking about electric, suppose somebody will tell you what is the potential, you show me. What you will do? You will do some big
capacity.
You should so you will do some big things and you will show that yes, I am having this potential. Yes or no? Yes or no? So yes. Here, what you will, how you define? It is the capacity. That means potential. What you do? It's an English term. It's a capacity. Potential means show your potential. So that means show me your capacity. Yes or no? So it is the capacity of a charged body to do what? Simply, simple sentence tell. Capacity of a charged body to do what? Clear to all of you? I always tell that you speak simple sentence. No infinity to point y. Why so much difficult sentence you tell? Somebody will ask you what is the electric potential? Capacity of a charged body to do work. Am I clear to all of you?
Yes, ma'am.
To do work. Chetna, are you there or not? Chetna?
Yes, ma'am, I'm here. Yes, ma'am.
Okay. Then, yes. So here, the capacity of a charged body to do work is called as electric potential. So, electric potential is denoted as capital V. This is equal to work done because capacity means you will consider the work done divided by charge. Okay. So this is equal to W divided by Q. Okay. So this is unit is how much? Unit is what? Unit of electric potential is your
Volt.
volt. Work done is in joule. This is your joule divided by coulomb is
Coulomb.
your what? Is your volt.
Volt.
Okay. So how you define 1 volt? A body is having a potential of 1 volt. How you define? A body is a charged body, obviously, is said to have a potential of 1 volt. Said to have a potential of 1 volt. Who are the new students? Tell me your name. New students joined just last class. Tell your name.
Yes, ma'am. Ma'am, Vibhu Kalyani.
Vibhu Kalyani. Any hand from boy side?
Ma'am, Utkal Sahu.
Ma'am, Neil Jain.
Okay. All of you understood?
Yes,
Yes,
ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, very good. A body is said to have a potential of 1 volt. When you will tell that the body is having a potential of 1 volt? When you will tell? If
Energy consumption, ma'am. If
why
how much
energy,
energy
you
is
define.
consumed?
Simply you define from this equation. Why
Then
you are going to energy?
1 joule of work is done in moving 1 joule of
One, yes, ma'am.
1 joule of work is done to give
By a body of unit
To
charge.
move a
joule
one charge of
of-
coulomb.
yes, work is done when you will do 1 joule of work to give a body to give it or to give a body to give it a charge of how much coulomb?
1 coulomb.
1 coulomb. Okay, so when you will do 1 joule of work to charge it or give a charge to a body to body of 1 coulomb, then you will tell that the potential is 1 volt. Now coming to the potential difference. What do you mean by potential difference? What do you mean by potential difference? Yes, tell me.
मैम
Priyam, Priyam,
infinity से हम
tell.
लोग
Yes, tell me.
मैम जो इलेक्ट्रिक पोटेंशियल में हम लोग फ्रॉम इन्फिनिटी कंसीडर कर रहे थे उसी को किसी एक डिफाइंड पॉइंट से अगर कैलकुलेट किया जाए तो वो
Again, same thing. Again, same thing. You are telling so much difference in potential between two charged bodies. Potential difference means what? You are having a one charged body here, another charged body here. Okay. What is the difference in the potential? That is your potential difference. So how will you define difference in potential? Difference in potential. तुम लोग सब 12th स्टैंडर्ड में इतना बड़ा बड़ा सब डेफिनेशंस याद करते थे? So long definitions.
No, ma'am.
करना पड़ता था
कुछ तो याद नहीं करते थे, वो तो एग्जाम कुछ नहीं दिया और क्या?
Yes, ma'am. नहीं दिए.
हाँ,
हम नहीं देने के लिए तैयारी तो किए थे ना मैम
मैम सिर्फ फॉर्मूलाज पढ़े हैं.
कुछ
Yes,
तैयारी
ma'am,
नहीं.
formula
जनवरी से बैठे थे, कब एग्जाम कैंसिल हो जाएगा? जब 10th
मैम,
का
हमने
एग्जाम
exam
कैंसिल
दिया
हो
मैम.
गया, दुख में बैठ गए. क्यों हम लोग
ट्विटर पे मैम ट्रेंड चला दिए थे मैम हम लोग.
अरे मुझे सब पता है.
मैम हमने एग्जाम दिया मैम, इन्होंने नहीं दिया.
कौन एग्जाम दिया?
हमने दिया है.
हमने दिया मैम.
क्या कौन सा एग्जाम तुम दिए हो?
मैम बोर्ड एग्जाम मैम, हम ड्रॉपर्स हैं.
ओ अच्छा.
Yes, ma'am.
मैं वो तो तुम लोग तो एक्सेप्शन हो. मैं जो
मैम फ्लेक्स कर रहे हैं मैम सब दे के
वो
बोर्डिंग.
2021 पास आउट है, वो तो कोरोना बैच है. ठीक है, तुम लोग का कुछ टेंशन नहीं था, जनवरी से बैठ गए थे, कुछ पढ़ाई वढ़ाई नहीं.
नहीं मैम जेई का टेंशन था.
कैंसिल हो गया.
इसलिए इतना बड़ा सब सेंटेंस याद करके तुम लोग बैठे हो. हाँ
हाँ मैम 3-4 मार्क्स का आता था तो डेफिनेशन इसलिए करना पड़ता था.
अच्छा, ठीक है. यहाँ पर तुमको 0.5 मार्क्स में, यहाँ पर भी बड़ा बड़ा 3-4 मार्क भी होगा, तो इतना ही छोटा सा डेफिनेशन लिखना, ज्यादा कंप्लीट क्लमजी करके हिस्ट्री जैसे आंसर मत लिखना। हिस्ट्री जैसे आंसर में देखूंगी पूरा 0 कर दूंगी, ठीक है? पूरा टू द कंसेप्ट पिन पॉइंट आंसर तुमको चाहिए। इतना टाइम किसी का नहीं है तुम लोग हिस्ट्री जैसे आंसर पढ़ेंगे, मुझे पता नहीं वो लोग 12th में कैसे सब लोग चेक करते हैं, ठीक है? Simple sentence is difference in potential between, sorry, here I have written between two charged body. Okay, between two charged body. Then when you are having two charged bodies, suppose this is a charged body having 3 volt, this is a 5 volt, the difference is your 2 volt. Okay, if there is, this is a 3 volt body, this is a 3 volt body, there is no potential difference. No potential difference. Current will not flow when there is no potential difference. Current will only flow when there is a potential difference. Here there is a potential difference, so current will flow from higher potential to lower potential. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so now what is the unit? Simply unit is also volt. Unit is also volt. Unit is volt. How you define this potential difference as 1 volt? So here potential difference between 2 points or 2 bodies, potential PD I am writing potential difference between 2 bodies or 2 points, 2 bodies or 2 points, whatever you can write down, if both are correct, is 1 volt. When you will tell it as 1 volt? If 1 joule of
1 joule of energy being used by 1 coulomb
1 joule of energy or work is done in transferring what? 1 coulomb
of charge
from one point to another. From one point to another. Okay, clear?
Yes, ma'am.
So these are all. Now, have you heard a term EMF? EMF and yes, electromotive force. What is this force? Tell me. What is the difference? What is the unit of this electromotive force? Electromotive force unit is also volt. Unit is also volt. Okay. So what is the difference, tell me, of potential difference and EMF? Tell me. This is a force, okay? This is a driving force for the current. You are having a battery, right? When you are having a potential difference, that means it is having a force. That force is called as EMF, electromotive force. That means it is having a driving force. Okay, if you are taking a voltage of 0 volt, it does not have any driving force. EMF is 0 implies there is force is 0. Electromotive force is 0. It does not have any driving force for the current. If you are having a electromotive force of 5 volt, unit is your volt, then this is having a driving force of 5 volt and a current can flow. But if you are having an electromotive force of 0 volt, then there is no driving force. That means there will be no current. Okay, so electromotive force is the driving force for the current. What is the difference between them? Between the potential difference and the EMF. This is the driving force for the current. Yes, tell me.
Ma'am, EMF, it is independent of resistance of the circuit.
Independent of resistance of the circuit. Independent of the resistance means its value is not depending upon the resistance. Its value is not depending upon the resistance, or what you are telling. Let it be wrong.
Yes, ma'am.
Internal
Yes,
resistance.
मैम वो डिफरेंस बिटवीन द टर्मिनल्स होता है मैम ईएमएफ.
हाँ, यहाँ पर में I have taken two bodies also. यहाँ पर भी the difference in the terminals है. यहाँ पर 2 point, ये first point है, ये second point है. यहाँ पर एक difference है. यहाँ पर भी एक driving force है. यहाँ पर एक EMF है. What is the difference then? You are having here also. This is a positive. This is negative. You are having a EMF. Okay, what is the difference between this?
When nothing is connected,
EMF ओपन सर्किट में भी हो सकता है. But
Ma'am, the difference is the current, ma'am. Charged particles.
Difference in the current? No.
Charged particles.
Difference in the charged bodies.
ma'am, when nothing is connected, then it is called EMF.
No,
Ma'am,
nothing is connected.
Yes, ma'am, to the battery, then we call that this battery has this much
No,
EMF.
no, no,
Ma'am,
no.
EMF is the
You cannot.
maximum potential.
Yes. Just wait. Somebody was telling. Here, I will connect a resistance. We will call it as an EMF source. If I am not connecting, I am having a battery. Suppose you have purchased a battery. That is an EMF source. That is a EMF, electromotive force.
मैम लाइक मैम पोटेंशियल डिफरेंस मैम सर्किट क्लोज होगा तो ही मैम हम लोग उसका पोटेंशियल डिफरेंस ले सकते हैं मैम. ईएमएफ
When no current is drawn from the cell.
See, if a EMF, yes, I am making it you clear. Okay, if a EMF, you are having, suppose EMF of 4 volt. You are telling a battery or EMF of 4 volt. It is the measure of the energy the battery gives to each coulomb of charge. Okay, it is the measure of energy. When you are telling that the electromotive force of the battery is 4 volt, that means it is meant that the energy, it is the measure of the energy the battery gives to each coulomb of charge. That means it will supply 4 joules of energy. It will supply 4 joules of energy per coulomb. Am I clear to all of you? It will supply how much energy? This battery will provide 4 joule of energy per coulomb. Am I clear? Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
All of
Yes,
you are
ma'am.
okay.
No, ma'am,
This
can you
may not be
explain once
required.
more?
See, these things which I'm telling you, these are all very basic things. It may not be required for exam point of view. Always don't relate everything for the exam. You will get good marks and I am telling you all this for your basic knowledge, basic things. Okay. Maybe you will not get these basic questions because already you have read it in your 12th standard. But the concept, very basic concepts would be clear before going to the DC circuit. So here,
EMF will gain energy.
Tell me.
EMF will gain energy then and potential.
No. EMF is not gaining energy. You are having an electromotive force of 4 volt because unit of electromotive force is 4 volt. So here, this means that you are having a 4 volt battery implies that it is a measure of energy the battery is giving to each coulomb of charge. That means if you are having a 4 volt, that means it is providing 4 joule of energy per coulomb. Am I clear now? Am I clear
Yes,
now? This energy is given to each coulomb in a battery due to the chemical action or chemical reaction. Understood? Now coming to the potential. Now we'll go for the potential difference. There will be clear. Potential difference between, suppose you are having a 2 bodies A and B. You are having a body A, you are having a body B. Okay. Suppose the difference is your 4 volt. Okay. So how you define? Here 4 volt implies that each coulomb will give up an energy of 4 volt each coulomb will give up an energy of 4 joule in moving from A to B. Again, I'm telling you. Each
Yes, ma'am. That's
coulomb,
losing energy.
yes, losing energy. Each coulomb will give up an energy of 4 joule in moving from A to B. Am I clear now? What is the potential difference and what is EMF? Clear to all of you? All of
Yes,
you
ma'am.
understood what is the potential difference, or is there any doubt? Tell me. You should know. Somebody may ask you, what is EMF? EMF is having a unit volt. Potential difference is having unit volt. So what is the difference between potential difference and EMF? Understood, all of you? Got it? So 4 volt is having a potential difference, means each coulomb will give up energy of 4 volt. 4 joule in moving from A to B. I think I'm clear. Understood, all of you?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes.
Yes, ma'am.
So you are having class at, I think, 2 o'clock, or you don't have class?
Lunch, ma'am. Lunch time.
Lunchtime.
Last class. Okay. Okay, you take lunch. Tomorrow next class. Acha, tomorrow you are having class.
No,
No,
ma'am.
ma'am. Tomorrow holiday, no, ma'am. Panchayati Divas.
Tomorrow is holiday.
Yeah, ma'am.
Yes,
Yes, ma'am. Ma'am,
Panchayati
Panchayati Divas.
Panchayati Raj
What
Divas.
is that Panchayati Raj Divas? Huh?
Don't know, ma'am.
Don't know,
Joined in
ma'am.
the-
फॉर्म ऑफ गवर्नमेंट फॉर्म हुआ था.
Why don't know? Everything you will tell don't know. It's a good answer, na?
Ma'am, I think on that day that Panchayati like formed, government body formed.
ये भुवनेश्वर स्टूडेंट्स क्या ओडिशा स्टूडेंट्स कैन टेल दे कैन स्पीक इट इज द बर्थडे ऑफ
Manmohan Singh.
Manmohan Singh. Who is telling? Birthday of what? Who can tell?
Chaiti Raj.
Biju Patnaik.
बीजू पटनायक. गूगल में देख लिए ना? तुम लोग तो ज्यादा स्मार्ट हो गए हो नहीं? बीजू पटनायक. बीजू पटनायक was बीजू पटनायक?
Chief Minister. Former Chief Minister of Odisha.
नवीन पटनायक का फादर.
हाँ, नवीन पटनायक का फादर, फॉर्मर चीफ मिनिस्टर ऑफ ओडिशा. ओके.
Yes, ma'am.
So his birthday has been declared as Panchayati Raj Divas by our government, Odisha government. Okay. So that is a holiday for Odisha, and because your university is in Odisha, so it is a holiday. Okay. I have taken you the attendance. Leave.
Thank you, ma'am.
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 Thank you. Thank you.
Ma'am.